All right, so in this problem, the Turkish twist, you have, it's like a drum, just like, in your washing machine, if you had a top-loading washing machine, which is the next problem. So if you can do this problem, you can do the next problem because it's the same diagram pretty much and the same picture. So you're going to have here's the drum, and you're going to have the person up against the wall of the drum as it spins. And as long as it's spinning fast enough, the person will stay stuck up against the wall. Well, the only force on this person that's keeping them moving in a circle and not in a straight line is the wall behind them. And that's a normal force. And normal forces are always perpendicular outward from the surface. So the normal force is in that direction. So that's going to be Fn. Now in this problem it says, what radius should the ride have if we can safely make the floor drop away when it reaches its running speed? And we know what the running speed is. It's given in the problem as 0.5 revolutions per second, or a half a revolution every second. We don't want the person to slide down the wall when the floor drops away. So we want enough friction. We want enough friction in this direction to overcome the weight of the person in that direction. So we're going to have, this is W, and this is the friction. I'm almost on autopilot to put normal force when I have that, but it's friction in this problem. So once I have that, then my descriptive equations. I'm going to sum up my centripetal forces, and the only force in the centripetal direction is the normal force. Now, I'm going to set that equal to either mv squared over r or mr omega squared. And I told you that if the radius is the unknown, in order to get the correct answer, then you're going to use mr omega squared. Okay, you don't want to use mv squared over r because the v has r's hidden in it, and I need all my r's exposed if I'm solving for r, if r is my unknown. So that's my equation in the centripetal direction. And in the y direction, it's going to be friction minus W equals 0. Well, if friction minus W equals 0, then friction equals W, and W equals mg, so friction equals mg. So now I have something that I can replace for friction. I can say friction equals mg. Well, I know friction equals mu Fn, and that's Fn. So I want another form of friction. So I'm going to take, knowing that friction equals mu Fn, that's going to equal mu, and then for Fn, I'm going to replace Fn with mr omega squared, so that it's mu mr omega squared. So I know friction equals that. I know friction equals that, and I know friction equals that. So this equals that. Those two I can set equal to each other. So I can write that mu mr omega squared, which is friction, equals mg, which is also friction, I have over here. And what can I cancel from both sides? M. And let's see, the unknown in the problem is r. So I'm going to rearrange this equation to solve for r. So I just need to move those two to the other side. So r is going to equal g divided by mu omega squared. Well, the g, we know it's a constant, 9.8 meters per second squared, and the mu was given in the problem. What we don't have is the omega, so I'm going to have to figure out what the omega is in radian. I do have an omega. That's an angular velocity, but it's not in the right unit, so that has to be in radians per second. So somewhere, you're going to solve for omega. So I'm going to take 0.5 revs per second, and I can do that in one step. I'm going to go from revs to radians. 1 rev is 2 pi radians. So basically that's pi radians per second, because half of 2 is 1. So I'm going to write that as 3.14, which is pi, radians per second. And then plug it in above. So I'm going to put in 9.8 meters per second squared, divided by the mu is 0.20, and omega squared. Make sure you put the parentheses in first so that the square is on the outside, not on the inside. Some of you may have noticed that you're losing some points because you're doing that. That's why I have parentheses, because the number gets squared and the units get squared. So this one I'm going to put in 3.14 radians per second. So again, you can ignore the radian as a unit. It's sort of like a fake unit, again, that gets us from a linear or tangential to a translational unit. But I'm going to have the second squareds. We'll cancel the second squared, and I'm left with meters. So if you take that and solve it, you're going to get the final answer was what? 4.97? Really? With those numbers? I'm going to put it myself just to make sure. I'll change it because I've had 4.97 for so long. Nobody's. Oh. Yeah, you get 4.969, so 4.97 with 3.14. So that's the answer for that one. Any questions on that? Now, if you can do this one, you can do 8 because